Good morning, students. Welcome back to another virtual session of subject statistics. We'll be continuing with our section E, question number 3. Again, repeating that this particular exercise of section E of exercise 4 is not there in your syllabus. Starting with the first sum, that is limit x plus h raised to 7 minus x raised to 7 upon h. Now, taking that x plus h is equal to t, when h tends to 0, t will tend to x. Limit of t tends to x, t raised to 7 minus x raised to 7 upon t minus x, because x plus h is equal to t. Putting in the standard format, that is limit x tends to a, x raised to n minus a raised to n upon x minus a is equal to n a raised to n minus 1. So we get the value of n as 7 and we get the value of a as x. So n minus 1, that is 7 minus 1, gives us the answer 7 into x raised to 6. Moving on to the next question, that is question number 2. Limit of x tends to 0. In the 10th root we have 1 plus x minus 1 upon denominator x. The limit in x tends to 0, what is given is in the root, that is 10th root, 1 plus x minus 1 upon x. So we get limit t raised to 1 upon 10 minus 1 raised to 1 by 10, because 1 plus x is equal to t. Again, taking the whole thing, that is when x tends to 0, t tends to 1, we get limit t tends to 1, that is t raised to 1 by 10 minus 1 raised to 1 by 10 upon t minus 1. Putting that in the standard form, we get limit of x tends to a, x raised to n minus a raised to n upon x minus a, where that will give you the output of n multiplied by a raised to n minus 1. So in this sum, we get the value of n as 1 by 10, the value of a as 1, and n minus 1 will give you 1 upon 10 minus 1. That is, taking the LCM, we get minus 9 by 10. Further simplifying that, we get 1 upon 10 into 1. So that gives you the answer 1 by 10. Moving on to the third question, that is limit x tends to 0, 1 plus x raised to n minus 1 upon x. So when we take 1 plus x is equal to t, when x is equal to 0, t tends to 1. So we can take a limit x tends to 0, 1 plus x raised to n minus 1 also raised to n upon x. Now putting that in the standard form, where 1 plus x is equal to t, we get t raised to n, because 1 that is replaced by 1 plus x. 1 plus x is replaced by t. So we get t raised to n minus 1 raised to n upon t minus 1. We get that in the standard form, that is limit x tends to a, x raised to n minus a raised to n upon x minus a. So the final answer, as discussed earlier, we get n into a minus 1. Now here the value of n remains n and the value of a is changed to 1 raised to n minus 1. So n multiplied by 1, we get the final answer as n. Moving on to the fourth sum, we get what is given is limit x tends to 1 by 2, fx minus f into 1 by 2 upon 2x minus 1, where fx is equal to x square plus x minus 1. Now here fx is equal to x square plus x minus 1, because therefore f1 by 2 is equal to, putting the value of x as 1 by 2 square plus 1 by 2 minus 1 in the function fx, that is x square plus x minus 1. Students, welcome back to another virtual session. I will be continuing with section E of exercise 4, question number 3. Find the values of the following. First 3 sums we have already done in the previous video. Now continuing with question number 4 of third. The question is limit x tends to 1 by 2, fx minus f1 by 2 upon 2x minus 1 as the denominator, where fx is equal to x square plus x minus 1 as given in the question. Let us start solving. As given, fx is equal to x square plus x minus 1. Now putting the value of 1 by 2 in this equation, we get 1 by 2 is f1 by 2 is equal to 1 by 2 square plus 1 by 2 minus 1. When we take a common LCM, we get, that is 4. We get 1 plus 2 minus 4, that is equal to 1 upon 4. Now, using the limit function, that is x tends to 1 by 2, fx minus f 1 by 2 upon 2x minus 1. The numerator portion, in that we can see when we put fx value, that is x square plus x minus 1, in f1 by 2, that is plus 1 by 4 upon 2x minus 1. When we solve the numerator portion, what we get is 4x square plus 4x minus 3, and the final factors as 2x plus 3 into 2x minus 1. The step above that is factorizing, that is 4x square plus 4x minus 3 can be factorized as 4x square minus 2x plus 6x minus 3, wherein we get the final factors as 2x plus 3 into 2x minus 1. And in the denominator we get as 4 2x minus 1. Finally solving that, we get limit x tends to 2, 2x plus 3. In the value of x, we will put 1 by 2. So, we get 2 into 1 by 2 plus 3. That is 2 gets cut. So, we get 1 plus 3 upon 4. So, that is equal to 4 by 4 equal to 1. Going down to the next question, that is question number 5. We get limit h tends to 0, f into x plus h minus fx upon h, where fx is equal to x cube. So the answer is how to solve, that is fx is equal to x cube is given. Putting the value of x as x plus h, we get over here as f into x plus h, that is x plus h cube. So x cube plus 3x square h plus 3x h square plus h cube. It is written h square, actually it is h cube. Then moving on to the next, limit h tends to 0, fx plus h minus fx upon h. Putting the value that we already got for expanding x plus h cube, we get x cube plus h cube plus 3x square h plus h cube minus x cube. The final answer after eliminating the similar terms with opposite signs, what we get is 3x square h plus 3x h square plus h cube. Moving on to the next, that is taking h common, we get 3x square plus 3xh plus h square upon h. H gets eliminated from numerator and denominator, so we get 3x square plus 3xh plus h square. Now putting the value of h as 0, we get 3x square plus 3x into 0 plus 0 square. So the final answer that we get is 3x square. Moving on to the next sum, that is 6. Limits h tends to 0, fx plus h minus fx upon h, where fx is equal to x raised to 7. So we get over here fx is equal to x7. So putting the value of x as x plus h, we get x plus h raised to 7. So x plus h is equal to t. When h tends to 0, t will tend to x, using the format of standard form. So limit t tends to x, t raised to 7 minus x raised to 7 upon t minus x, because x plus h is equal to t. So we get the value in the standard form as x as 7, n as 7 and a as x. So 7 into x raised to 7 minus 1, that is 7 into x raised to 6. That is the final answer.